Welcome to the viewers. Now we discuss the derivative and meaning of derivative. First order derivative. Generally we write it dy dx. Then we call what does it mean for dy dx. What is the meaning of the derivative? At first, let y equals to fx be any function, basically in the real valued function we consider, and we consider the graph for y equals to fx in this way, and here is the point, that is, suppose if it be x1 and it's another point that is x2, and if we join this, so here what does the meaning of derivative, what is the meaning of derivative? So actually derivative that comes from the incrementation word. What? The variable increment. Actually x for the function x1 x2, if the change of the function, that is y plus del y, that will be f of x plus del s. That means if the increment of y where del x del y are increment of x and y, if we consider from the representations, that's del x, only this region that will be considered as del x. Now corresponding we find f of x1, here is the value, and if we consider it as a y1 is equal to f of x1, and here y2 is f of x2, so correspondingly we find the increment of del y, only this region, it is change. So here from the given figure, del x is equal to x2 minus x1, and del y, that will be y2 minus y1 minus y2. And if we change y1 minus y2, that's a curve of decreasing curve. Here if we consider increasing one, then we say this, but it will be y1 minus y2 for the actual given figure, and better to say these differences actually, no matter for that. Maybe the curve is increasing or decreasing. The curve is here monotonically decreasing, that's why these things happen. But if we consider another curve that will be increasing, then corresponding x2 minus x1 we find y2 minus y1. Now here y plus del y equals to f of x plus del x. We rewrite y of f of x. Therefore we calculate del y from here, f of x plus del x minus y, and this y equals to fx. So we calculate del y, and we know the value of del x actually when del x tends to 0, that means, that is from here x2 tends to x1, because x2 minus x1 tends to y, then we can say this corresponding y2 tends to, that is y2 tends to y1, that means, because this is for the value of the y2, if we consider that then y2 tends to y1, that is y2 minus y1 tending to 0, that is del y tends to 0. So what we conclude, when del x tends to 0, that means x2 tends to x1, then y2 tends to y1. That means this curve is converted to a tangent simply. Here it is a curve and this is chord 2 point, but now this curve converted to a tangent on a single point. These things happen. So this will be the tan theta, negative of theta, whatever maybe it is, maybe negative or positive, because this is a decreasing function, that's why negative result comes. But when we find increasing function, that will be positive. But no matter for that, this will be the theta, tan theta. By definition, tan theta, that will be given by sin theta by base perpendicular by base, that's why del y by del x. Therefore by definition we find del x tends to 0, so del y tends to 0. By definition of derivative, limit del x tends to 0, when del x tends to 0, we finally find the ratio del y by del x, that will be the slope of or tangent, is equal to dy dx. It is by definition, that is dy dx equals to limit del x tends to 0. What we find here, del y is f of x plus del x minus fx by del x. Now we finally find our desired result. This is the meaning of dy dx. Actually it is a slope or tangent we find. If we calculate the theta is the angle of inclinations, then tan theta, that will be given by dy dx, our definitions. And with the help of this result of the first order derivative, we can find for different value function, we can calculate different derivative with the help of this formula, and laterally it will be discussed. Now we end our discussions. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.